Hi guys, good morning. So in the last session, we have seen about STP and RSTP, and today we'll be starting with a new concept, which is about Ether channel, right? So guys, anyone, what is Ether channel? What do you know about Ether channel? Yes. Combine two ports only? Mhm. Bandwidth and Hmm?
Redundancy.
Speed and redundancy. Okay, understand? We know that, let's say if I'm using two switches, okay, and if I try to have redundancy, normally what do I have? I have a single link here between the two switches. This is your switch one, and this is switch two. Switch one and switch two, right? So here what is happening? I'm using only one link. Let's say F0 by 1, or in our case, according to the topology, this is Z0 by 0. This is also Z0 by 0. So what is the bandwidth I'm having here? I'm having here 1 Gbps because gigabit link, right? So if I try that, okay, I need to update my network, I need to upgrade my network, I need higher speed. So in that case, what I can do, I can try something like I can connect two links. So when I connect two links, what is going to happen? That Z0 by 1, this is also Z0 by. So this is also 1 Gbps. Now, how much I'm supposed to get here? Hmm? What is the amount of total bandwidth now I should get here?
2 Gbps.
2 Gbps. But how much how much I get? 1 Gbps. Why? Why I get 1 Gbps only? Is in backup. Maximum speed is, that is for one link, right? 1 Gbps only for one link. 1 Gbps is there only for one link. But what will happen? Your protocol, STP, will see that, okay, there is a possibility of loop. What the STP is going to do? Block a link.
Blocking on board.
Will do what? Block this link. So eventually, how much did we get? 1 Gbps only, right? Now, what is Ether channel? With the help of Ether channel, what we can do? We can combine multiple physical ports. These two ports, let's say we can combine into one. These two ports we can combine into one. And we'll get a logical port. That will be known as what? Port channel 1. This will be known as what? Port channel. Same way, this is the interface port channel. So now what will happen? Instead of seeing these links as two different links, STP will look at it as a single link, as a one single link. And is there any possibility of loop through one single link? No. To have redundancy, you connected two links, but that redundancy didn't work because of STP. You were having redundancy, like if one of the link goes down, then second link will be up. But if the first link doesn't go down, second link will always remain in blocking state. So whatever the money you spent on the second link is what? Just waste. If the first link is not going down, right? So we want to use both the links so that we get higher bandwidth also. And even if one link goes down here in this case, still we will have redundancy. So redundancy benefit is there, but other than that, we have speed and increased speed and bandwidth. Is that clear? So ether channel is what? You can say ether channel is a way of combining multiple physical ports into a single logical port. A way of combining multiple physical ports into a single logical port. Clear? Okay. Now, if we talk about ether channel, so ether channel provides us several benefits. Benefits. What kind of benefits? Number one, increased bandwidth. Number two, redundancy. And also number three, one link is not having all the load. So that means load balancing is also there. Load balancing is also there. Understood? Now you see here that, on these two sides, we configure ether channel. Okay, so we have different ways of configuring ether channel. Your ether channel can be configured in two ways. Number one, manual, that is basically static. Number two, we can dynamically configure. So where we will be using protocols. What kind of protocols? Either LACP or AG. These kind of protocols. Clear? Now, ether channel, when you will configure, so you will configure on both the sides. Okay. So there are some criteria that must match on both sides of the link for the ether channel to come up. Okay. So if I talk about criteria that must match for the ether channel, come up. So number one criteria, link speed should be same. Speed of link must be same. Number two, your duplex setting must be same. Okay. Number three, if it is a trunk interface, native VLAN must match. Okay. And number four, switch port mode. That means if the port is configured access or trunk. So either access or trunk. That also should match. These are the criteria for the ether channel. Is that clear? These are the criteria for ether channel.
Sir, it is for both manual and as well as dynamic, right?
Yes.
Okay.
This is clear. Okay. Then next thing. How many links can be combined in ether channel? So if you are using protocol LACP, With the help of LACP, you can combine 16 links. With LACP, you can combine how many links? 16 links. At a time, 8 will be active and remaining 8 will be in the standby. Remaining 8 will be in the standby. This is clear? Okay. Then we have number 2, PAGP. Here you can combine 8 links only and all 8 will be active. All 8 will be active. This is clear. Then we have third one, that is static or manual. If you are statically configuring, again you can combine 8 links. So the general idea is you can 8 times increase the bandwidth. Doesn't matter which one you're using. But with LACP, what is the benefit? That if one of the link goes down, one standby will come up. So that means your eventual bandwidth will not get affected. But in case of PAGP or static, what will happen? If one link goes down, bandwidth reduces. Okay. But in LACP, we have the facility that automatically one standby will come up. So our eventual bandwidth will not get affected. Clear? Okay. Then after the configuration part, let's say if we talk about difference, difference
Sir,
between
LACP and PAGP both are open standard.
no. That's why I'm telling you difference.
Okay.
Difference between LACP and PAGP. Two major differences. There are two major differences. So first one, LACP. Then let's say PAGP. So I have LACP, which is basically open standard. Okay. And we have PAGP, which is Cisco proprietary. Okay. LACP. So we see that here how many links can be combined? 16 links. Okay. LACP can combine 16 links, out of which 8 will be active and 8 will be standby. While PAGP can combine only 8 links. This can combine only 8 links. That is the major difference. This is clear. Here the mode is active or passive. And here the modes are auto and desirable. This is clear. Here the modes are auto and desirable. Note it. Now, let's say you want to configure LACP. So first thing we know, I'll just copy everything from here on. The points about LACP. So according to LACP, what happens? If we have two switches, so I'll say switch 1 mode, switch 2 mode, and then trunking. Sorry, not trunking, ether channel. That whether or not ether channel will come up or not. Okay. So if the switch 1 mode is active, switch 2 mode is active, ether channel will come up. Okay. If this is active, this is passive, ether channel will be up. If this is passive, this one is active, the ether channel will be up. If both are passive, in that case, ether channel will not come. Clear? Yes or no? For PAGP, okay, one more thing here. LACP stands for Link Aggregation Control Protocol. While PAGP, Port Aggregation Protocol. This is Port Aggregation Protocol, and this is Cisco proprietary. Can combine only 8 links. Modes are auto and desirable. So first one is auto, second one is auto. Ether channel will not come up. First one is desirable. Second one is auto. Ether channel will come up. First one is auto. Second one is desirable. Ether channel will come up. Then both are desirable. Ether channel will come up. Okay. Like this you can see. Clear? Static. So static is not a protocol. So we don't have to say like it is some sort of protocol and how many links. So only 8 links it can combine. Okay. So if I go with the static, so what this is manual way of configuring Ether channel. This is manual way of configuring Ether channel. Okay. Can combine 8 links and only one mode. Mode is only one mode, which is on. This is clear. Okay. Then about configuration, that how do
Sir, can you please give the explanation or about port channel as well?
port channel is the same thing. Ether channel, port channel, same.
Oh, both are same, huh?
Yeah, both same.
Okay.
Yeah. The Ether channel interface name is what? Port channel.
Either channel interface is called as port channel, right?
Yeah, port channel.
Okay.
Yeah. So when it comes to configuration, so you say just select the interfaces. Okay, so you will say interface range of interfaces, and then you can say if you are using the protocols, in that case you will say channel protocol, and you will mention whether or not LACP or PAGP. Okay. Then you will say channel group. Here you will give a number. Mode. And depending on the mode you will give here, the protocol will be selected. Like you can see here, active, passive, auto, desirable, or on. Just based on whatever you will give here, based on that, the channel will be decided. That clear? Clear? In Ether channel, there is also load balancing, right? So we'll come to the configuration. First, let's understand about load balancing. Ether channel load balancing. If you want to check the Ether channel load balancing, to check Ether channel load balancing method, you can use the command What is the command? Show Etherchannel load balance. This is the command. Okay. By default, source destination IP load balancing is enabled. Okay. By default, the source destination IP load balancing is enabled. Okay. Ether channel load balancing can be done on the basis of, you can do it on the basis of destination IP, destination MAC, source destination IP, source destination MAC, source IP, source MAC. On these basis, you can do the load balancing. And by default, which one is enabled? Source destination IP. Clear? Understood? Online people clear? Yes, sir. Okay. Now let's see the practical, if you noted. All right, let's see. Oh, it's for FHR, not for it. I'll take 4 switches, or instead of 4, let's take 2 only. In one single topology, I'll show you all. So I have switch 1, then I have switch 2, switch 3, and switch 4. Okay. Z 0 by 0 with 0 by 0, 0 by 1 with 0 by 1. Then 0 by 2 with here also 0 by 2, 0 by 3 with 0 by 3, then Z 1 by 0 with 1 by 0, and Z 1 by 1 with 1 by 1. Start all the switches. So this side, one protocol we will use. This side, another protocol we will use. On this side, static method we will use. Okay. So one side we will use LACP. Here we will use LACP. Here we will use PGP. And here we will use static. Okay. So here the mode will be active. Here also active. Here the mode will be auto. Here we will have desirable. Here we will have the mode on. Here also. Clear. Access switch 1. Switch 1. Then switch 2. Switch 3. Switch 4. All the 4 switches. Okay. So enable configuration terminal host name. Switch 1. Host name. Switch 2. Host name. Switch 3. Switch 4. Now take a look. Switch 1. If I say do show spanning tree, you will see one of the link is blocked. So right now this guy is what? This guy is the root bridge. So what is happening? That his all ports are designated port and in the forwarding state. What about switch 2? Let me do one thing. See, right now we are using only two ports, right? So remaining all the ports I will shut down so that it will not create confusion like this, so many ports. Okay, so let me quickly do it. interface range Z 0 5 3. Here we have interface range. This is having 2 and 3, right? Here we have 1 0 and 1 1. Okay, all the unused interfaces I have shut down from the switch. Because in EVNG, it will by default show all the switches. I mean, all the interfaces. Now take a look. Show spanning tree. So if I take a look, here both the interfaces are up, designated port. But if I go and check on the switch too, if I say show spanning tree, so you will see that my ports Z0 by 1 is blocking. The Z0 by 1 port is what? It is in the blocking state, right? Now, switch 3, show spanning tree. One of the port is blocked here, Z0 by 3. Then switch 4 is also having a blocked port. So spanning tree. Everywhere one of the port is blocked. Not a good idea, right? So what we'll do, we'll configure Etherchannel and these ports will come up. Right now, if I check show Etherchannel summary, so you will see that there is no Etherchannel configured. You can see there is nothing configured. We are not getting anything. So now what? Let's start configuration. So this side we are configuring LACP. Interfaces are Z0 by 0 and 0 by 1. So I'll say interface range Z0 by 0 to 1. I'll say channel protocol LACP. Then I'll say channel group. And you can see I can give a group number between 1 to 255. So I'll say channel group 1. Now, then go on the switch to. Now, interface range, again, here also 0 by 0 and 0 by 1. Global configuration mode, interface range Z0 by 0 to 1. Channel, protocol, LACP, channel group, 1, mode, active. Then you will see that it was saying LACP is not enabled on the currently remote port. But now it is enabled and you can see my interface port channel 1 change state to up. My ether channel successfully came up, right? Normally, if I check do show interface Z0 by 0, that what is my bandwidth of an interface? You can see what is my bandwidth here, 10 raised to power 6 kilobit, right? 10 power 6 kilobit. And if I check for my port channel interface, do show interface port channel 1. Now you can see Isn't it double? Is it double or not? It is just the double. 2 into 10 raised to power 6 kilobit. Okay. And if I check Etherchannel, to show Etherchannel summary, you can see my port channel 1 is, the code is S and U. S means it's a layer 2 Etherchannel and status is in use. What is the protocol running here? LECP. And what are the ports available inside the port channel? 0 by 0 and 0 by 1. Clear? Yes or no? Online people? Now coming to how many ports we can combine. So if I say do show Etherchannel, you can see I'm running the LECP. And this is a bug here, that maximum I can use 4 ports. In LECP, maximum you can use 16 ports. This is clear here? Okay. Now, this side we have run the LECP. Now let's go with the PAGP this side. So switch 3, I'll configure. Interfaces Z0 by 2 and 3. Okay. So I'll say, okay, one more thing I'll show you. That on switch 2, earlier one of the port was blocking. You see Z0 by 1 was blocking. Correct? But now if you check, do show spanning tree. So I have my port channel 1 and it is in the forwarding state. I don't have the interface E0 by 0 and 0 by 1. Clear? Okay. Now let's go on the switch 3 and configure. Interface range E0 by 2 to 3. Channel protocol. And this time PAGP. Channel group. Now group number 1 is already used on that side, right? But here also, this is switch 3. We didn't configure anything here right now. So here we can use group number 1. See here, when I configured LECP, so group number 1 is already configured for this, right? This side I'll configure group number 1. This side I'll configure group number 2. Okay. So channel group 1 mode, let's say this side I'll say desirable. Done. Go on the switch to interface range G0 by 2 to 3. Channel protocol. And here PAGP. Channel group 2 mode auto. Okay. So interfaces are down. Then it will create port channel interface. And once it detects, port channel will come up. You see here, line protocol is up on that ports. And you see port channel interface change state to up, right? Okay, now let's check. Do show spanning tree. First of all, here I have port channel 1 interface, root state. Okay, it will go in the forwarding in some time. Then if I say do show spanning tree, you can see, oh sorry, it's not spanning tree, Etherchannel summary. So you can see port channel status is up. Layer 2 port channel status is up. What is the protocol here? PAGP, interface Z0 by 2, interface Z0 by 3, both are bundled inside the port channel. This is clear. Now third, let's go with the static. So if I go and check the static one, so this side interface Z1 by 0 and 1 by 1, and mode is set to 1. Configure terminal, interface range G1 by 0 to 1, and directly we will say channel group, because this time it's not a protocol. So channel group 1 mode on. Now on the switch 2, we have already configured group number 1 for LECP, group number 2 for PAGP. So this time here we will configure group number 3. So go on the switch 2. interface range G1 by 0 to 1. Channel group 3 mode is on. Now our channel group will come up. You see here, port channel 3 interface change state to up. Port channel is up. Now we can see here to show ether channel summary. So this is not a protocol, so the protocol name is not there. Okay. Protocol name is not there. Okay, then interface Z1 by 0, 1 by 1, they are bundled inside the port channel, and SNU, that means layer 2 and up. This is clear. Now on switch 3, we have configured all the three, right? So if I check here, to show ether channel summary. So here you can see I have port channel 1, 2, 3, LACP, PAGP, and static. This is clear. Okay. So this is the way. And right now the ether channel we have configured, it was what kind of ether channel? Layer 2 ether channel. How to configure layer 3 ether channel? So we just need to convert the ports into layer 3. That's it. Is that clear? So let's say what I'll do is these two. Let's say here I want to configure what? L3 ether channel. So what I'm going to do is I'll go here and just disable L2 features. Interface range Z0 by 0 to 1. First of all, I'll say no switch port. And this will do what? This will disable the L2 characteristics on the interface. Okay. And same thing I'll say here also. Interface range Z0 by 0 to 1. I'll say no switch port. Once I did give this command, then this ether channel will be converted to L3. Okay, port channel interface came to up. Let's check again. So if I check, do show ether channel summary. So this time, what do I have? Okay, S and D I have. So wait for it. Also on the switches, we have enable IP routing for L3. IP routing. Okay, let's do one thing. I'll default the interfaces and then default interface V0 by 0 to 1. Default interface V0 by 0 to 1. Done. Now, first of all, IP routing enabled on both the switches. IP routing here also. IP routing. Done. Then after, go to the interface range Z0 by 0 to 1 and disable the L2 characteristics. No switch port. And here also, interface range Z0 by 0 to 1. No switch port. Done. L2 characteristics disabled. Now, give the channel protocol. Channel protocol LACP. Here also, channel protocol LACP. Then we will say channel group 1 mode active. Command reject. Okay, already I think. Let me give no. Previous configurations are still there. So that's all. Now channel protocol LACP. Done. Let's check. Do show running interface 0 by 0. I don't have anything right now. Okay. So now channel, protocol, LCP, channel group 1, mode active. Command rejected, either port is L2 or port channel is L3 or vice versa. Why is that? We can do one thing. This would be stop all the nodes. We will wipe switch 1 and switch 2. Sometimes this kind of issue will happen. Switch 1, switch 2. Both the nodes, I have wiped the configuration. Start. Start. So comments are, how do you configure for Ether L3 Ether channel? First of all, you will enable IP routing on the switch. Then you will say interface range, and here you will give the range of interfaces. Then you will say, switch port. Then you will say channel, protocol, either LACP or PGP. Then you will say channel group, number, mode, and then you'll give the mode. Auto, disable, active, passive, yeah, on. Okay, whatever the mode. Just think of it. Okay. Got it? So let's see. Switch 1 access. Then switch 2 access. Switch 0 by 0. Enable configuration terminal, hostname, switch 1. Hostname, switch 2. Paste. Now, first of all, what we will do is we will enable IP routing. IP routing on the switch. Here also IP routing. Then after we will say interface range is 0 by 0 to 1. Okay. And I'll say no switch port. So that interface will turn into L3. interface range Z0 by 02. Sorry, 0 by 0 to 1. No switch port. So now the interface is L3. Okay. Then we will say channel protocol. Okay. LACP. Same thing here. Channel protocol LACP. Then we'll say channel group 1 mode active. You see now it's working. Channel group 1 mode active. Working now. And you can see port channel interface will come up. Okay. Interface came up. Do show Etherchannel something. So you can see this time it is not SU, this is RU. R means this is a layer 3 Etherchannel and this is inputs. And these are the ports. Remaining everything is same. Just you have to enable IP routing and no switch port on the interfaces. This is clear? Okay. Then channel load balance. So this is the command port channel load balance. And you can see what type of load balancing is supported: destination IP, destination MAC, source destination IP, source destination MAC, source IP, and source MAC. So here where we mentioned, right? So you can copy, I mean, you can note down this command also. This one. That these are the supported ones. To set load balancing method. Okay, you can use the command. And no. Port channel load balance, and then you can set the mode. Clear? Not it? And the default one. So you can use the command do show first channel load balance. And you can see what is the default one. Source destination. Understood? Okay. So this is about Etherchannel. Okay. Now, next session, we will discuss about the next topic, which is about, I guess, FHRP we will discuss. Yeah, FHRP we will discuss. So tomorrow FHRP, and then the next session L2 security, then we are done. Okay. Any doubts?
Sir, channel group number, there is no concern, right? If it is different, it will
Yeah,
bundle.
yeah, correct.
Okay.
Yeah.
Then what about the difference between L2 Etherchannel and L3 Etherchannel?
No,
In case of
they won't communicate, right?
No. So suppose in the interviewer may ask what is the difference between L2 in Etherchannel and L3 Etherchannel? How can we answer?
Same difference. In the L2 Etherchannel, ports are behaving as L2. I mean, the L3 Etherchannel, they are behaving as L3.
Okay.
Okay. Yeah. Yeah.
Thank you, sir.
Okay. All right, guys. Then see you tomorrow. Have a good day. Bye.